Hello and welcome everyone to my channel Code with Ease by Varsha. Today's video is one of the most requested and maybe one of the much awaited videos. That is a crash course on arrays. Today we are going to cover anything and everything that you need to know about arrays. So whether you're a beginner or just starting out to learn, or maybe you're a working professional, this video will be a great fit for you. So if you're a beginner, we are going to cover everything from scratch. So a lot of hands-on code examples and all will be there. But if you are a working professional or an intermediate learner who already knows about arrays, this can be a quick refresher for you. So you can just watch the video at a recommended speed of maybe 1.5x. So today's video is divided into 5 parts. We are going to first start off with the introduction overview, why arrays are important, various code samples, we are going to do hands-on, and then we'll dive deeper into different ways of initializing arrays. The most interesting part is going to be we are going to analyze every operations of arrays, the various operations that we can do in array, along with the time complexities. And then we are going to wrap things up by talking about multi-dimensional arrays, dynamic arrays, some bonus tips and tricks, common mistakes made while using arrays. So that is the plan of this entire video. At the end of this video, I'm hoping you'll be equipped with all the knowledge that you need to confidently work with arrays. So let's get started.
Okay, so starting with the arrays crash course. First part is introduction. First question, what are arrays? So arrays, as we know, it is a data structure. What is a data structure? It is a way to store and organize different values. So arrays are the most fundamental and the most commonly used, most popular kind of data structure that we use in different programming languages. And two characteristics are very important for arrays. One is it is having a fixed size. Okay, we will explore more on this. What does it mean? And secondly, the homogeneous elements. When I say homogeneous elements, I mean, like it is said in the second point, it is able to store the collection of values, but they should be of the same type. What is type? Type means like we have built-in types for every language. Like if I'm storing marks of a student, that is in integer, numeric type. If I'm storing names of the student, that is string. Okay. If I'm storing any temperatures, that is going to be decimal numbers, like the floating point values. So the type of the elements that I want to store in my data structure should be of the same type. So it is guaranteeing the homogeneous nature of the elements that we are storing. And third thing is, of course, it is able to store multiple values. So that is why we are saying collection of values. So these three things are important. It is having a fixed size. It is storing same type of elements in it in its data structure. It is storing same type of element in itself, and it is able to store multiple values. So that is what are the three main characteristics of arrays. Okay, so now how are arrays represented in memory? So this thing is very important to understand. This will form the understanding of the other data structures even better. This is like the basis, the foundation. So like we said in the previous slide, arrays are having fixed size. And why they are having fixed size is because they are represented in the memory continuously, like it's a single block of storage. We'll understand a little more deeper, like what do we mean by the blocks of memory, how they're actually represented. We'll see that in a while. And every element in the array is stored at a sequential. So these keywords are very important. Contiguous block of memory, sequential memory location. When we are able to pinpoint to these keywords, when we will see the diagram in which we will explain. So then it will become even more clearer. And thirdly, when we are trying to access an array element, if it is beyond the limits of the array, it can result in some error and exceptions. So although we have not discussed about how do we declare and initialize an array yet, but let's say I have an array, of 5 integers, like 5 marks of students. Okay, so we usually denote it in the inside a square braces. So I have all the marks denoted for the students. Okay, so these are the 5 different marks stored in an integer data type. So integer is a primitive data type like we know in Java. And in Java, if it's a 32-bit system, the size of the integer data type is 4 bytes. It will, in memory, it is going to take up 4 bytes, every integer variable, 4 bytes. Now, I have 5 students, 5 different marks of the students. So, how much space is it going to take? 4 into 5, 20 bytes. So, assuming this is my memory, it starts from here till here, and then there are several blocks of storage in the memory. My 5 students, this marks is going to take up 20 bytes of memory. Let's say 20 bytes of memory is this much. Okay, so this much space it is going to occupy. And that is the reason we have mentioned about the contiguous block. Whenever arrays are being stored in memory, it happens in the way like it is a long stretch of a tape. Like contiguously they are stored. It's not like some marks is stored over here and some marks is stored over here. It is not stored randomly. That is what linked list does, but not array. Array is going to store all the data together in one memory. It's like it is going to block off a certain section of the memory, and there only it is going to store. And that is also going to bring us to this point of fixed size. When we are declaring an array, we hard code the value of the size of the array. If I'm saying I want an array size 5, so I'm telling the memory management that please allocate 20 bytes contiguously in the memory. That much space is occupied, it is blocked. Okay, so this much space is blocked by 5 array elements. Okay, now what happens is the accessing part, right? So one point is done, second is the sequential memory location, now third is the accessing. So usually, as we will see later in the slides, how do we access the array elements? It differs from one programming language to another. In Java, we use indexing. Okay, so indexing can start from 0 in some languages, or it can start from 1. In Java, it is 0. So we say, let's say the name of the array is ARR. We say ARR of 0 is always going to be the first element. So 50 is nothing but ARR of 0. ARR is nothing but the name of the array. It can be marks of 0 or anything. So this is the first element. The first element will sit over here. So 50. So this is the starting address of this array. So if at all I have to reference this array in the memory, I have to reference it using the first element. So this is the starting address of the array. Okay, now what happens? Let's say this location is 100 and this is taking 4 bytes, so this is 104. Now, how are the other elements being placed? So what is the formula is? The formula is starting address that you have plus the index position, that is 0, 1, into the size of the data type. So if my starting address is 100 and I have to store 60, what is the index position is 1. So 100 plus 1 into what is the size of my data type is 4. So 100 plus 4 is 104. So my starting location for storing this 60 is going to be 104. What is the starting location of 70? Same formula, 100 plus the index position is 2. 2 into 4 is 8. So 108. So it will be stored at 108. So 104 to 108 is being occupied by 60. 108 plus again 4, 112 will be occupied by 70, and so on. So this justifies our point of sequential memory location, how they are stored in contiguous blocks of memory. And now why the accessing of the array element can result in this memory access error. So I have allocated how much, like 5 bytes, how much, like 20 bytes. So 70 is being stored, and then 95, and then 90. So like I was saying, this much memory space is pre-allocated or blocked in advance. Now, if I am doing some incorrect array indexing, let's say I'm saying ARR of 5. So my last index is 4. There is no ARR of 5 at all. Okay. So when it is trying to calculate, what it will do, 100 plus 2 into 5, that is 120. And at memory location of 120, there is no element at all. And that is why the error is going to come. So that is why we have to be very careful when we are talking of the indexing. So this slide is all about the representation of the arrays in memory. Now moving on.
You guys have reached so far. I'm hoping you're liking the content that we have put out. So please make sure that you hit the big thumbs up button and like this video. And please don't forget to subscribe to this channel. Press the bell icon next to it so that you can never miss an update.
Next part is the creating and initializing array. So now how do we deal with arrays? First of all, how do we declare an array in Java? The common syntax or the generic syntax that we use is something like this. Like we discussed about types in the beginning. So what are built-in types? Like we can have numeric for integer, for names we can use string, char, for floating point we use float, double, all of that. So the notation is we first write the data type. So if I'm saying integer is my data type, then we give 2 square braces like this, and then the name of the array. What is the name of the array? Like the variable. So ARR of marks, let's say I'm just trying to declare. So this much part is only the way to declare an array. Don't worry, we are going to move to our IDE and we are going to see hands-on how we are trying to write the code for this. So we're going to do all of that. So just to give you an idea of how do we declare an array, this is the way to declare an array. Okay, next is how do we initialize. Okay, the first question that can come to the mind, what is the difference between declaring an array and what is the and initializing an array? Declaring an array means I'm just saying that, okay, I want to create a variable called ARR of marks, where I want to basically I want to create a array which is going to store my marks of the student, and I want to store that of the type integer. That's it. At this point, when I'm declaring my array, I'm not able to store anything as such yet. I'm not able to add any marks to my array yet. So this is just a declaration. I'm just declaring, hey, I'm just going to create an array and now I'm going to store the marks of it. So just declaration. Initializing is where the actual work happens, where you start adding values to your array. There are 2 ways to initialize an array. In the first example that you can see, this is called static initialization. And the second example is, this is called dynamic initialization. What is the difference? So before equal to, what we see is the declaration part, right? After that, we are using a curly braces and we are putting all the numbers 1, 2, 3, 4, 5. So I am stating that, okay, I'm creating an array called my array, and please add 1, 2, 3, 4, 5 these numbers into my array. So this is my array. Just add 1, 2, 3, 4, 5. So this is static because well in advance I'm declaring what are the elements I want to store in the array. But if you see in the second example, the convention is the same. Before equal to I'm declaring the array, but I'm using a different keyword called new. We call this the new operator, and then we are writing int, again the type of the data type, and then we are saying in square braces 5. What does it mean? We are saying that allocate in the memory, allocate some space for 5 elements of integer type. It's like fill in the blanks. Okay, so just allocate 5 places in the memory for 5 elements which are going to be of type integer. Why it is dynamic? Because I don't know what these values of these 5 integers are going to be yet. These are blank values. Okay, ideally in Java this gets stored by default, all the values are initialized to 0, so that's a different thing. But what I'm trying to explain is here I am saying that please store these specific values. In the second example I'm not specifying anything, I'm just saying give me a space worth of this much size. So this is the size, and new operator we are using to allocate memory to this. Okay, moving on. How do you access individual elements? So now that we have stored all the elements, now let's say I want to access a particular number that I've stored. So for using that, I mean to access the individual elements, again we are going to see that in a while in the code demo. So what we are doing is we are using the index of the element and the array variable name. So for example, if this is my array, how I am trying to access the element, which is the third element, I am just saying my array 2. Now question arises, why? There is a concept of indexing which is used in different programming languages in different ways. If we talk of Java, array indexes start from 0. So when I say 1, 2, 3, 4, 5, the indexes will be like this: 1, 0, 1, 2, 3, 4. Okay, 3 and 4. The size -1, like whatever the size of your array is, -1, till that much will be your index. From 0 to that much, size -1. So I have 5 length, the array's length is 5, and my last index goes till 4. So when I'm saying my array 2, basically I want to access the element at index number 2. So it is returning me the element 3. Clear? Next, using arrays in Java program. So like we said, now we are going to talk about the common operations that we use to deal with arrays. Firstly, accessing. So like we just saw in the previous slide that we were able to access the elements using the name of the array variable name and whatever the index position is. Another operation is modifying. Now I have an array, I want to modify the elements. So that can be another operation. Next is finding. I have a length, I have an array and I want to figure out what is the length of that array. Next, searching. I want to search for a specific value. The famous algorithm, linear search, is based on that. Sorting. So we have so many different sorting algorithms: bubble sort, insertion sort, quick sort. So it is all about how do we want to sort the elements in our array. Then looping. So looping is the most basic and the essential concept that you have to know, because unless you are able to traverse or loop through the elements of the array, you will essentially be not able to do any complex task. Now with that, let's move on to see the code demo of all the different operations that we are doing along with the time complexity. So now let's do hands-on of the different operations. So starting with first, how did we declare an array? Int, and then the square braces, and then the name of the array variable, and then this is what we were doing to, statically initialize our array. So let's do that. We'll see the other way. So I'll just call this static ARR. And another way is the dynamic way of initializing. So dynamic ARR, in that I'm just using the new operator and I'm using new int size equal to 5. So these are the two ways of initializing the array. Next is we want to access a particular variable. So let's say I want to, okay, before we do that, let's see how do we add elements to our array. So I have this dynamic ARR. Now I want to add elements to this. So first thing what we have to do is, there are two ways. Manually I can say dynamic ARR and then set the value at index 0 equal to 8, and then again copy this line, and we'll say at index 1 I want to store value 10, and so on. As we can see, it's a very hassle. As we can see, this is too much of a hassle to do, because individually I have to initialize all the variables. So this is not a good way. The better way would be to try to use some kind of loop structure so that we can insert the elements at the different indexes of the array. So we'll see that, but let's start with the basics. So first part is accessing. So first we want to access the array. So how do we do that? I want to just print out at the static array, I want to print the value of the index position number 3. So let's try to run this. 0, 1, 2, 3. So at index position 3, we have the value 4. Okay. The next thing is what we want to do is, okay, so now if we have to talk about the time complexity, what is the time complexity? Okay, if you guys are not sure what is the time complexity and all that we are talking about, it is the performance implication of the code that we are writing, how much time it is going to take. Anyway, I have done a detailed video on that. We already have a playlist of time and space complexity series. If you people have not checked it out, please check out the links in the description. So time complexity of this is going to be what? I did not have to travel through 1 or 2 or 3. I just simply I just tried to access the element at this location. The time, so it is going to be constant. I don't have to wait for the entire input to be traversed. Like we have discussed, time complexity is always, sorry, it is going to be big O because that's the notation. Because I don't have to wait for the, I don't have to depend on the input. My input size is 5. I don't have to wait. I don't have to depend on the entire input. I can directly access. So direct access is what is causing the fast and efficient access. So that is why we had mentioned in that slide that arrays benefit is fast and efficient access. Next, the next operation is modify. Okay, how do we modify? So for modifying, what we will do is, let's say this is my array and I want to change the value at index position number 2, which is 3. I want to change it to 10. So what I'll do, static ARR, the index position is 2. So what I'll do, static ARR at position 2, I'll just change it to 10. Okay, so I've changed it to 10. Now how do we know if it has changed or not? We'll try to print the array. Let's see. What do we get? We are getting some random mix of numbers, alphabets, characters. Because when I'm trying to print the array, I'm not trying here, it seems like I'm trying to print the content of the array, but what it is actually printing the memory address of that array, which I don't want. I want to print the contents of the array. For that, we use a special utility class called arrays, and then we use a method called toString, which takes in the parameter of the various types of arrays like integer array, byte array, char array. So I'm going to pass in here the value of my arrays. So over I'm going to pass in the value of my array. So now if I'm trying to print this, now I can see the value has changed from 3 to 10. Again, time complexity. Did I have to traverse to the entire array? No. So again, big O of 1. Next operation, finding length. Now often, or maybe in most of the cases, you might be required to find, you're given an array, you might have to first know the length of the array, right? Even if you write a loop or something, which you will see now, you need to know the length of the array. How do we know that? There is a special property of arrays only, which is called static ARR.length. So this is a property. If we use that, we will be able to see what is the length of the array. Length is 5. Okay, if I add one more character, okay, sorry. Now, what is the time complexity of finding the length? Again, same thing. I don't have to traverse to, and I just directly access my property. Order of 1, constant. Next operation, search. This is the linear search algorithm. So for understanding the search, the other thing that we have to understand is how do we loop through the array. And when we know how do we loop through the array, many things will get solved. We will be able to initialize values also into the dynamic array. We will also be able to search for the element. So for that, we'll use a for loop. Int I equal to 0. Why? Because the index starts from 0. I less than, pay attention, static ARR, that is the name of our array, dot length, less than this, I plus plus. So I'm looping through this entire array. Why is it less than this? Because the length is 5, and as we have seen, the last index position is size minus 1. So I have to go till 1 minus the length. So that is why it is less than. Now this is the way to loop. So what I can do, very first thing, I can just say I want to access the position at position I, whatever the value is, printed for me. Okay, so I'm just going to maybe comment out all of this so that it doesn't confuse. Now I'll run this. 1, 2, 3, 4, 5. It has printed all the values. Now the other thing what I wanted to try out was, instead of printing, I want to populate values inside my dynamic array. So let's do that. I'll just add dynamic array at ith position. I want to say I plus 1. So this is like, I don't want to hard code a value. So if I am at I at 0, my first element is going to be 1. If I am at I equal to 1, my element at my 1th index is going to 1 plus 1, 2. So let's, okay, we also have to print it out. So I'll just print out the dynamic array now. Same thing, arrays dot toString, and then dynamic array. Let's run this. 1, 2, 3, 4, 5. So, okay, I'll just change the formula a bit because so that you can understand what we are trying to do. 2, 3, 4, 5, 6. So when I is equal to 0, it is 0 plus 2, and then 1 plus 2, and then 1 plus 3, like that it goes on. So we have populated values. So what we learned? We populated values of a dynamic array. We learned how to loop through an array. We also learned how are we accessing and then printing the elements. So many operations we have learned. What is the time complexity when we are looping through an array? Because we are traversing through all the elements, so it is going to be order of the length of the array. Let's say the length of the array is n. So order big of n is the time complexity. Okay, so now coming back to our operation of searching for the elements. So I want to search. So again, if I have to search, I mean I don't know where my element lies, right? So let's say I want to search for target equal to 5 in my dynamic array. I don't know where 5 is. I don't know the access, the index value of that. So what I'll do, I'll again use a loop. So I'll use this loop. I'll just copy paste. I'll use this loop. So for the searching, I want to search for this target in my entire array. So I don't know where the array's index is, right? So what I'll do, I'll just use a condition. If the static ARR, okay, I think I will try to search it in my dynamic ARR. So if dynamic ARR's ith index, whatever the value is it equal to my target that I'm looking for? If it is, then please print out the index, like where is that element actually, and what, break. So I'll just break the loop. Done. I don't have to traverse any further because if I've already got the element, I'll break. This is the classic linear search algorithm. Okay, so I will keep this part where I have already initialized the array because this is where I am putting the things into my dynamic array, and then run this. So let's see. So 2, 3, 4, 5, 6, and this is the index number 3, like we told 0, 1, 2, 3. At index 3, we have the element 5. So we got this, and we are able to print at this index, we found this array. Okay, so what is the time complexity of this searching algorithm, whatever we wrote? Same thing, we are looping through the array. What is happening? In line number 31, where I'm just comparing, I'm not doing anything. What I'm doing is mainly in line number 30. So big O of n, traversing through the array or the looping through the entire array. So searching is also done. What are we left with? Sorting. Okay. Okay, so we can use arrays dot sort, and then we can pass in whatever array that we want to pass. Okay. Because our arrays are already sorted in ascending order, so we'll just try to tweak things a bit. Let's say I change the value at my dynamic array at index number 2. Let's say I put 17, and then at index number 4, let's say I just put some random value 23. So in that way, I've changed my values of this dynamic array. Now I will use arrays.sort, and then I'll print my array that I have. So I'll just print it before and after, like before sorting and after sorting, so that we can understand what's the change that has happened. So if we can see, initially after we modified the array, it was 2, 3, 17, 5 and 23. Disrupted the order. Okay. So now after sorting, it has sorted it in the ascending order. So this is how, using the sort, the built-in function, we are able to sort the array. Time complexity. The general time complexity of any sorting algorithm is, like, the best case is n log n, like quick sort and merge sort. These algorithms are having that kind of time complexity. So for Java's built-in sorting methods also, like the arrays.sort that we are talking of, the best case time complexity is going to be n log n. So to summarize, what are the things that we have done? We have learned how to declare initialize array. We learned how to access, how to modify, how to find the length of an array, how to loop through the array or traverse through the array, how to search for a particular element in an array, and then we also learned how to sort the elements of an array. So all of these complexities, so all of the common operations we have covered, and we have also seen the different time complexities. Okay, so now let's move on to the next slide.
You guys have reached so far. I'm hoping you're liking the content that we have put out. So please make sure that you hit the big thumbs up button and like this video. And please don't forget to subscribe to this channel. Press the bell icon next to it so that you can never miss an upload.
Okay, so starting with the next segment, that is part 4, multi-dimensional arrays. So the first question, what are multi-dimensional arrays? So far we have studied about arrays which are having only one dimension. So these kind of arrays are having more than one dimension. They're usually referred as like array of arrays. And this is the general syntax of initializing multi-dimensional arrays. So the classic example of this, like the more real world example, will be a usage of a table or a matrix like we have studied. So they are having two properties, rows and columns. So when I'm talking of 2 dimension is what I mean by that. One dimension is the row, another dimension is the column. In the earlier arrays that we have studied, they were having only 1 dimension. Like it was only one row and several columns, if you can visualize like that. Something like this. I have this array. This is row number 1 and all of these are different columns. So it is just doing a 1 dimension. But what if I have a box or a table like this divided into multiple rows and then multiple columns? So if I want to represent a data of this sort, then I have to use multi-dimensional arrays. Or since this is having just 2 dimensions, I can call it 2D arrays. If there are 3 dimensions, that will be 3D arrays and so on. So now let's do code demo 2. Okay, so now starting with the multi-dimensional array demo. So if you recall, we had a general syntax of using, okay, so first step is we have to create one 2D array, okay. So what do? Initially, we were using the data type and then we were using one pair of square braces and initializing. In this, we'll use 2 pairs of square braces because it is 2D array. Then I'll say, so I'll just call it array 2D and then new end. So this much is remaining the same. Now again 2 square braces. So earlier also we were having 1 square braces when we were dealing with 1D arrays. Now we'll have 2 square braces. And in the previous implementation we saw inside this square braces we are putting the numeric value which is denoting the size of the array. So in this case also we are going to denote the size of the array. Let's say I put over here 3 and then another 3. So what it means, I want to create a 2D array of size 3 rows and 3 columns. That is 3 cross 3 matrix. Okay, so my initialization of the 2D array is done. Now I have to add values inside of this. How do I add values? Okay, so the notation for this, so I'll just move on to the whiteboard to explain the notation of this. So like we said, there is a matrix and I have a 3 cross 3 matrix, means I have 3 rows and I have 3 columns. Okay, 3 cross 3 matrix. So when we were doing fixed array, so when we were doing 1D array, we know that it starts from 0, then 1 and 2, like the indexes. Over here also it is the same concept because it is array of arrays. Consider like this portion is actually a 1D array only. So it is like multiple 1D arrays stacked together, right? So here also it is the same concept, 0, 1 and 2. Here on the left hand side, these are the different columns, 0, 1 and 2 for first row, 0th row, first row, second row, or the first row, second row, third row. But since we are starting from 0 index, so we say like that. Now the question comes, how do I access the element? By what index I allow access my element? If I have to access the element over here, what should I say? We will say we want to access the element at row number 1 and column number 1, right? This is what the location of the element is. What is the location of this? It is at element is at row number 2 but column number 2, correct? This one, row number 2, column number 1, that's it. So this is how we are going to access the elements or add elements at a specific location. So the first box or the first number inside the square brace is denoting the rows and the second box is denoting the column. So that is why in the general syntax over here we have this rows and then columns, and then the rest of the syntax I have anyway shown. So moving on to the ID again. So this is a way of like, so in line number 5 what we did is the dynamic initialization like we were doing. So I have not added any elements, but I've just straight away declared and I've just stated that 3 elements are going to be there. Basically 3 cross 3, so 9 elements are going to be there. Now what if I want to do a static initialization? How do I do that? Okay, so for doing that I'll use the same data type integer and then 2 square brackets and then I'll just give the name static arr 2D, and now I'll just hit enter and give first pair of curly braces. Hit enter. Again another pair of curly braces. So I'll start adding my elements into my 3 cross 3 matrix. So as we said, array of arrays. So I'm having one array and then multiple arrays within the same array. Then I'll hit enter 4, 5, 6. Then again hit enter 7, 8, 9. So this is how my inside. This is the array of arrays. So outer one is one array, one big fat array, inside that multiple arrays. And then I'll put a semicolon. So this is how you do the static initialization of the 2D array. So we are done with that. Next is now we have to access. So for accessing now, let's say, firstly I have to, so for accessing, like I said, I want to access static ARR's this array. I want to access the element number 6. So which row is this? Row number 1. Which column is this? Row number, column number 2. And I want to print it out. Okay, let's run this. 6, I'm able to print. So this is how we are able to access. Now the main part, the iteration or the looping, where we have to use for loop, because this is not going to be as straightforward as having just one for loop, because one for loop will traverse through only one array. if we have to traverse to multiple arrays, I need another for loop. Okay, so how I'll do this, I'll first write the same thing, int I equal to 0. Ideally, the first for loop is keeping a track of your rows. So I have 3 rows, so my first for loop has to run 3 times. Okay, so int I equal to 0, I less than, what is my array? Static arr dot length. So the length of this array again, okay, if you are not sure, you can also try to print it, static arr arrays dot length will be 3. So it will go from 0, 1, 2. Okay, I plus plus. So first for loop is keeping track of the rows. Now within this I'm writing another for loop, because once I'm into row number 1 or row number 2, I have to iterate through every elements inside that row, right, which is distributed in various columns. So for that I'll use another variable int j, okay, equal to, this is also going to start from 0 only. Now how many times is this going to iterate? Okay, you may say I'll again put static arr 2d dot length, because it's a 3 cross 3 matrix, so the length will be the same only. But what if I had a 3 cross 4 matrix? I have 3 rows but 4 columns. So who is going to tell me how many number of columns I have? Because this property will only give me how many number of rows I have. So for that, very common sense, if I am into this row of 1, 2, 3, how will I know this row has how many elements? Back to our array, 1D array concept. We are at this array. We used that array dot length. So how can I point to that? So I'll say static arr, the name of my array. For this, point me to the ith row. What is the ith row? Means the row number. So I'm at 0th row. Point me to that row dot length. So that row's length, give it to, so give me out that row's length. So I will be dynamic. When I'm at I equal to 2, it is going to point me to the third row. So give me third row's dot length, j plus plus. That's it. Now I will print out all the elements one by one. But I won't print in ln, I'll just print it. Okay, so how will I print it? Same thing. Static arr, first the row. Who is denoting row? I. Who is denoting column? J. That's it. And outside of this, I'll just print a new line. Okay, now let's run this. 1, 2, 3, 4, 5, 6, 7, 8, 9. We could have given a space or white spaces in between. That's okay. But this is how we are able to loop through the 2D array. Okay, this is one way of looping through the 2D array. Okay, there is another way of looping through the 2D array, and that is using for each loop. In that, I don't have to give this complex I, j pointers, and nothing is required. What we will do, outer for loop is keeping track of all the rows. Try to understand. This is an array of arrays. So I will say, how does a for loop this thing look like? Left hand side, we denote what variable or what type we are going to iterate through. So I will say I'm going to iterate through my row. Every row is an array in itself. So I'm going to iterate through every integer row. Over what? Over my this entire array what I have. So my first for loop is doing the same thing. It is iterating over every row only. Within this, what I'll write? I will say iterate over every column value. Okay, or I can say cell value. Okay, what is this going to iterate over? It is going to iterate over every row. Simple. So now I don't have to write all this I, j pointers. I am iterating over every integer array. Within that, I am iterating over that array's cell values. So I'll just print this out. What I'm trying to print, I'm trying to print the cell value. I'll just try to give one white space in between. Okay, so I'll just use a new line over here. That's it. Let's try to print. So in the last part, we can see 1, 2, 3. So it's nicely formatted like you want. So there are two ways. These are the two ways of iterating through the multi-dimensional other 2D arrays. Clear? Moving on to our next segment. Part 5, dynamic arrays. So what are dynamic arrays? This word dynamic, you guys have heard last time when we spoke of dynamic initialization and all. So anything that is flexible, adjustable. So that is what dynamic means. So what are dynamic arrays in Java? Any array that can change the size as and when needed. As and when needed, as in whenever the elements are added, it will dynamically add more space to it. And when it is removed, it will adjust it accordingly. Earlier, whatever arrays we have covered, those are having fixed size. Why I say fixed size? Because you might have observed that we are declaring the length or the size of that array in advance. If I'm saying 3 cross 3 matrix, means it is going to only contain 9 elements. If I want to add 10th element to it, I will not be able to unless I change the size. If I'm having 5 elements in my array and I want to add another element, it is not going to allocate another space to it and add the element 6 to it. It is not going to do that. We have to create another new array. We have to manipulate change the size of the array and then add. So that is what is the limitation of the 1D arrays that we have studied, 1D and the 2D arrays. They were not dynamic. So In Java, dynamic arrays are implemented using array list. It's a special class coming under Java collection framework. We'll see hands-on how do we interact with this array list. So let's move on to the IDE. So in Java, we use array list to implement the dynamic arrays. So let's see how do we use. So array list is part of java.util package. It will get imported. Then we use a pair of angular brackets. In this, we denote the type that we want to store. So let's say I want to store string and I want to create a list of fruits. So I'll name it as fruits, and then we are trying to initialize it using the new operator. Again, new array list, angular braces, parenthesis, and semicolon. So we are done with initializing. Next, I want to add fruits into this. So I'll say fruits dot add. So there's a method called add. First I'll add apple, and then I'll add cherry, and then I'll add banana. So just added a couple of fruits inside this array list. So adding the fruits are done. Okay, so now notice that I didn't have to specify that I have to add 3 fruits only. Okay, now let's see how do we print this. Like, I just want to see what all do I have. I'll just print out the list. So I have these 3. So I have these 3 elements of fruits added to my list. Now the beauty is, after that I can again go ahead and keep on adding. So if I add, let's say, pineapple, again I print it, it will simply add it. So I initially add 3 now. So this is what the flexibility we were talking of. Okay, you can add elements whenever you wish to, remove from it whenever you wish to. So let's say I want to remove fruits dot, I'll use a method called remove. So there are many different implementation. I can remove by hard coding the name of the fruit, or I can remove based on the indexes. So let's say I'll try to remove a fruit, banana, and then I want to print it. So apple, cherry, and pineapple. Banana is removed. Or I could have even given the index values 0, 1, 2. Here also the same indexing works. So in this way, we are able to add elements to the list without declaring the size in advance. We're able to remove elements from it without even worrying where the indexes are going to be. Nothing. Next is accessing. If I want to access a fruit at a particular location, so fruits dot get. Okay, I want to get the fruit at index number 0. Let's see what happens. Apple, because that is the first fruit. So using the get method, we are able to access. Using add and remove, we are able to add or remove elements to the list. Now I want to iterate. Okay, that is the main part. Let's use a for loop. So the beauty over here is I don't have to worry about indexes. I equal to 0, I less than this. I don't have to. I can use a simple for loop. What I can say, I can use string fruit, iterate over fruits. Simple. And print all the fruits. Let's run this. So here we have been able to traverse or iterate through the array list also. So now in the next slide, we are going to see a bit more detailed comparison, why we are using and all of that.
You guys have reached so far. I'm hoping you're liking the content that we have put out. So please make sure that you hit the big thumbs up button and like this video. And please don't forget to subscribe to this channel. Press the bell icon next to it so that you can never miss an upload.
So now that we have seen how array lists work in action, now what are the advantages of using array lists? First is it is dynamic, flexible, all of that we have anyway seen that, like, it can change the size whenever we feel the need to, but arrays will not be able to because it is having fixed size. Next, it is having built-in methods to add, remove, and access. So when I have to access the element, I have to give the position, like inside the square braces in case of fixed 1D arrays, I have to write square braces 0, 1 like that. But here I have methods to do that. Okay, I have to still give the index, but we have better built-in methods. Like when I'm trying to add or remove also elements into it, I am using the method to do that. I don't have to manipulate the indexes manually to do that. So that is another benefit. And then we can store objects of any class. Like in case of arrays, 1D arrays, which we have seen, we were seeing that we are able to use primitive types only, int, char, float, double, like that. But in case of array list, we can store objects of any class. So string is a class. Okay, so instead of a data type, it is a class. So we can store the objects of any class that we want. Like the most important example of this is I have an employee class. I want to store the data of employee. So in case of 1D array that we saw, or the 2D array, because it is primitive type, I will not be able to store my custom object, the objects of my custom class, like employee or a student. So that is where array list comes in handy. And then we have a quick list of all the advantages being mentioned in terms of their property, like dynamic size, it can grow and shrink, built-in methods, Type safety is there because it is going to allow elements of a particular type only at a time. Enhanced functionality, iterators, for each loop, we have already seen how we are able to traverse using the for each loop. Auto resizing, because I don't have to manage the memory at any given point in time that I have to shift elements or something. I don't have to do any of that. So this sums up the advantages of array list over arrays. Next, this is one very common hurdle people come across when they're trying to solve interview questions. You are being told, you're given an array sometimes and you have to convert into an array list, or you're given an array list, you want to return the output in the form of an array. So what are the ways to convert? The first one is I have an array list, okay, and I want to convert that to an array. So in the first example that we can see, I have all this fruits added. Now I want to convert this list into an array. It might be possible that my requirement is I want to convert this into a string array. So then we use this method called list.toArray. Okay. Within this, it's looking a little complex, but it's not very hard to understand. We are just trying to say that initialize, new operator is doing what? New string, as we have seen, is what? Allocating memory. So it is saying initialize some space in the memory with the size of the list. So I want to create a string array which can contain 3 fruits, because that is what the list is containing right now. List.size is 3. So allocate some space in the memory for 3 string, allocate some space in the memory for storing this 3 entities of string type. Okay, so that is what it is trying to do. The next example is, how do I convert? Now I have an array like this string array that I want to convert to a list. So one way is to traverse through the array and then list.add like that, we loop through it. But the handier way is to use a method. So it is doing what? It is initializing a new array list, and then within the parenthesis which was initially empty, it is just saying arrays.asList array. Now all of this usage of the methods and all will come in more, you can familiarize it, all the methods that we are using, it will be handy and easy to remember once we practice more and more. Otherwise you have to look up the documentation. But yeah, this is one of the most common implementations which even I had come across, so I thought of sharing of interconversion of array and array list. Moving on. Okay, so now we have the bonus slide where we will talk about what are the common mistakes that we have to keep in mind when we are solving array problems. The first is off by one error. So when we are working with for loops, it often happens that we are trying to increment, like add or subtract one or any number from the given index. So there we have to be very careful so that it doesn't occur that index out of bound exceptions. Like it starts from 0 and ends at the last index. So if you are coming to the very first element and then you do -1, it will go to -1, like negative -1, and there is no element at -1 location. Okay, it starts from 0. So that is wrong. Again, if you're at the last element and you're doing +1, so there is again index out of bound because there is no element beyond the last index. So these things we have to be very careful when we are working with loops. Next is incorrect array indexing. So like we know, indexing is starting at 0. Okay, so again, if we are not mindful when we are doing any kind of logical operation, when we are trying to deal with the array indexes, then again the same unexpected results can happen, the program can crash. Then not checking the array boundaries. So this is also a very common thing which happens, that we try to write our logic assuming it is going to work, but then it doesn't. The program fails, it crashes because we were not mindful of the boundaries of the array. So this comes with practice, so we have to be very careful. So the first 3 points are very much related to the indexing, handling it in loops when we are doing computation, so that we have to be careful when we are doing it. The next is forgetting to initialize the array elements. This is important so that we don't face any garbage values that can lead to incorrect outputs. I remember in one question long back, I was assuming that it is going to contain the value which I want, but then it resulted in completely different. So all the test cases failed, and that was because I had wrongly initialized the array element, and it was resulting in some garbage value. So yeah, that is something which we have to cross check, double check again and again. Then is not considering the edge cases. Again, I also face this. When the array is containing only, what happens when the array is containing only one element? What happens if the array is not containing any elements at all? These scenarios also we have to think when we are solving the questions. Then not optimizing for time and space. So Anyway, when we are doing questions on lead code, hacker rank, or code chef, we are supposed to optimize it for the time and space complexity. But if we are not doing any competitive coding, or we are not using any kind of online platforms for writing the code, even then we should try to optimize for memory usage. We should try to optimize for the performance of the code that we are writing. So that will help us to prevent memory wastage also, because like I said in the very beginning, that 5 bytes, 5 elements are being stored, so 20 bytes are being occupied. Let's say I pre-allocate memory of 100 students, and at this point I only have 10 students in my class. So why do I want to waste the memory of 90 more students? That is going to take up the memory and it's blocked. So that kind of things we have to be very mindful of when we are initializing an array, because it is eventually going to take up more and more memory if we are not going to use it, and that is going to lead to wastage, cluster hogging up, and program can crash. So these things we have to be very careful when we are doing. And on the same side, like the time complexity, like if we are not writing the loops correctly, if we are unnecessarily iterating over the array, the time complexity is going to take a hit. So that thing also we have to be very careful. And finally, we have a few practice problems for beginners, like because this crash course is meant to be from very scratch. So if somebody has no experience in arrays earlier, so these are some of the problems. I think this can be done by intermediate also. I have a mix of questions. So very beginning, I have like declare an integer, initialize it, print it. Then you can take user input and then print out the maximum and the minimum. So here some computation logic will be required. Then reverse the elements of the array of size 10. Print the second largest element, okay, and it can be of size 10. Values can be entered by the user. So all of this are like playing around with the arrays using your computation logic to write this code snippets. Then sorting an array is a very famous algorithm, bubble sort. So instead of using arrays.sort in Java, you are supposed to implement the sorting algorithm. Merge two sorted arrays is a very famous, I think, lead code question also. Merging of two sorted arrays, and merging two arrays is something that is very fundamental. This kind of operation will be required many number of times in different kind of questions also. So it's a good investment to learn. And finding the number of even and odd elements. This is simple. I think people who are advanced Java programmers can use lambdas and streams to do it. But yeah, as I said, it's for the beginners, for them to get a good grasp on arrays. So they should be trying out these problems. So yeah, that's all. I think that's a wrap on today's session. Thank you so much for watching the session today. And please don't forget to subscribe to the channel if you haven't already, and don't forget to like and share this content so that it can reach out to many others who can draw benefit out of this. And thank you so much again.